Chapter 18 talks about the analysis of variance between two factors. So in the book's example, it talks about the responsibility of crowds. So the two factors would be crowd size and the degree of danger. So they use a two-factor ANOVA or ANOVA, and it's a more complex type of analysis that tests whether differences exist among population means categorized by two factors or independent variables. So the main effect is the effect of a single factor when any other factor is ignored. So in the example, the one factor could be the crowd size, but for this you'd have to ignore danger, and then the other one could be danger when you ignore the crowd size factor. So the crowd size, they tested a crowd of 0, 2, and 4, and they put this in the columns of the tables. And then the degree of danger, being dangerous and non-dangerous, are in the rows. So while they're graphing the main effects, the steeper the slant, the larger the observed differences between the column means and the greater the suspected main effect of crowd size will be. And then also, main effects must be qualified because of such complexity between the variables. So, in a graph of interaction occurs whenever the effects of one factor of a dependent variable are not consistent for all the values or levels of the second factor. So, there are 3 F tests that the two-factor ANOVA tests. They also test onto the null hypothesis one at a time with 3 different F ratios. There's the F column, the F row, and the F interaction. So the F column would be of crowd size, the F row would be of the degree of danger, and the F interaction would be whatever variability there is remaining. Interaction occurs when two factors are combined and something else happens besides a composite of their separate effects. So this will be reflected in the F value. The book also talks about simple effects, and a simple effect is the effect of one factor on the dependent variable at a single level of another factor. So the main effect can be interpreted without referring to its two simple effects. Another thing is inconsistent simple effects. So this occurs when the simple effects do not line up. But according to the main effect, assuming that one exists, it cannot be interpreted without referring back to its radically different simple effects, even if they are different. When you are describing an interaction, you can describe it from the original interaction in 2 different ways, but you're still referring back to the original interaction. And the first type is portraying the inconsistent simple effects of crowd size for non-dangerous and dangerous conditions, or secondly, portraying the inconsistent simple effects of degree of danger for crowds of 0, 2, and 4. So both ways suggest the same interpretation of the data, that crowd size influences reaction times for non-dangerous but not for dangerous conditions.